Hey kids, it's time for discussion 3-2. We're going to be naming compounds and writing formulas for them in this discussion. All right, so let's talk about writing formulas for binary ionic compounds. So figure out each ion charge and figure out the ratio of ions that will create a neutral molecule. So I just want to let you know, when you look at the chemical formula for a compound, you may see some subscripts and superscripts. So the subscripts in the formula tell us the amount of each ion or atom in the compound. So for water, for instance, it's H2O. That 2 you see in the formula for water is a subscript. So that tells us we have 2 hydrogen atoms and 1 oxygen atom in the formula. Superscripts you will see as the charges on individual ions. Now, because compounds are always neutral, you will never see a superscript in the final formula for a compound. You'll only use them in the ions that we're using to figure out what the formula is. All right, so how do we write the formula for compounds? So the whole idea here is that the compounds are neutral. And we are going to have different charges on different ions. Now, in order for the charge of the overall compound to be neutral, however many positive charges we have from all of our cations, we have to have an equal number of negative charges. So just like when we figured out the charge on an ion, to figure out the charge on the compound, we have to add up all the charges together. If they add up to 0, then we have the correct ratio. If they don't add up to 0, we have to figure out how many of each ion we need in order to make the compound neutral. So step 1, we have to look at the elements involved and figure out what their charge is based on their location in the periodic table. We're then going to add the charges together and figure out, if necessary, how many of each we would need to write the formula. So let's go ahead and do that for sodium and chlorine. So sodium is in group 1, so the charge on its ion is +1. Chlorine is a halogen in group 17, so the charge on its ion is -1. Now I'm going to go ahead and add the charges together. If they already add up to 0, that tells me I only need 1 of each ion. So I take the positive from sodium, add it to the negative from chlorine. Indeed, they equal 0. That tells me 1 of each ion is enough to make this compound neutral. So the formula for sodium chloride is NaCl. Now let's try magnesium and nitrogen. A little less complicated because being in group 2, magnesium's ion has a charge of +2 and nitrogen's ion has a charge of -3. When we try to add the positive charges from magnesium and the negative charges from nitrogen, they don't equal 0. So now is where I have to consider how many of each ion I would need to make the compound neutral. So the only way I can change the overall charge is by adding more of each ion. 1 magnesium ion has a total charge of +2, so if I had 2 magnesium ions, they would combine to a total charge of +4. So the question then becomes, what's the lowest charge I could have? So the easy way to figure this one out is really just take the 2 charges you see there and multiply them together. I know that if I had 3 magnesium ions, I would have a total positive charge of +6. And if I had 2 nitride ions, I would have a charge of -6. So to solve this, I take the equation as it's written. If I multiply the positive charge by 3 and the negative charge by 2, then the equation becomes +6 plus -6, which equals 0. That tells me I need 3 of the positive ions and 2 of the negative ones to make the compound, so the formula is Mg3N2. So essentially we're just going to figure out what the charge of each ion is, and then write them into an equation and multiply each ion by a factor that balances everything out. So for this slide, I want you guys to practice. Look at the elements involved. So sodium bromide is sodium and bromine. Figure out what the formula, thus the charge on each cation and anion is. Based on that charge, figure out how many of each you would need and write the formula. So I will do the first 2 in the table and I'll have you guys work out the rest. So for sodium and sodium bromide, the cation is a sodium ion, and the anion is a bromide ion. I see the sodium is +1, and the bromide is -1. That means one of each is all I need to write the formula, and the formula is NaBr. Now let's look at calcium chloride. Calcium is 2+, and chloride is 1-. So I have to think about what the lowest charge they could possibly share is. Well, if I kept one calcium ion and had 2 chloride ions, that would make a total positive charge of +2 and a total negative charge of -2. So the formula is CaCl2. All right, in the same way, use the examples that we've done on this slide and the examples on the previous slide to go ahead and work out the next 4. So pause the video and go ahead and do that. Okay, so magnesium oxide is magnesium, which is a 2+ ion, and oxygen, which is a 2- ion. When I add 2 and -2, they equal 0, so one of each ion is fine, and the formula is MgO. For aluminum nitride, it's an aluminum ion, which has a charge of 3+, and a nitride ion, which has a charge of 3-. Again, the charges are equal and opposite, so one of each ion will do, and the formula is Aln. For aluminum fluoride, we're still dealing with aluminum, so it still has an ion with a charge of 3+, and fluoride, being a halogen, has a charge of 1-. So in order to make this neutral, I could stick with one aluminum ion and have 3 fluoride ions to make the total negative charge match the total positive charge. So aluminum fluoride has the formula AlF3. And finally, barium nitride. Barium is in group 2, so it's 2+, and nitrogen in group 15 is 3-. So just like with the example on the previous slide, I need 3 barium ions and 2 nitride ions to make the formula, which is Ba3N2. All right, so we talked in 3.1 about how you can figure out the charge on an ion simply by looking at which group it's always in. That is always true for the nonmetals, but some of the metals can have multiple oxidation states, more than one possible charge. So there's no way to just figure what the charge is by looking at the periodic table. So these compounds include the charge on the metal in the name of the compound. And we indicate that charge by using a Roman numeral. So here's an example of an ionic compound containing a transition metal, osmium-4 chloride. What that osmium-4 means is that osmium, the metal osmium ion, has a charge of 4+. When we're working out the formula, since there's no way to automatically know what the charge of osmium is, we give it to you in the name. So I have 4 units of positive charge from osmium. So the question is, how many units of negative charge would I need from calcium, or chloride, excuse me? Since each chloride is -1, I would need 4 of them. So the formula for osmium-4 chloride is OsCl4. Now, a lot of kids confuse this. This Roman numeral does not tell you anything about how many of each you have. So a lot of kids are going to think, oh, it's 4 chloride. That's why we have 4 chlorines. It has nothing to do with that. The Roman numeral only tells us what the charge is on the cation. And I can give you a really quick example of that. Let me just open up my dock camera here and flip that over. That's from the last video I made. So a good example of this is manganese 4. 4, I can do Roman numerals. Manganese, I can spell too, 4 oxide. So what that means is manganese here has a charge of 4+. Since oxygen or oxide has a charge of 2-, the formula for this compound is MnO2. The name of it is manganese 4 oxide. Notice there is no 4 showing up anywhere in that compound. The 4 just tells us that the charge of the metal is +4. All right, so go ahead and practice writing the formulas for these transition metal compounds. Same rules apply, only now instead of having to figure out what the cation is, the name tells us what it is. So pause the video and see if you can work this out. Okay, so chromium 3 means Cr3+, oxygen is 2-. That means we need 2 chromiums and 3 oxides to make Cr2O3. Copper 2 sulfide. Copper 2 means copper plus 2. Sulfur is in group 16, so it is 2 minus. Since the charges are equal and opposite, we only need one of each, and the formula is Cus. Manganese 4 oxide, we just looked at that. It means manganese 4, and oxygen is 2 minus. So that means I can just stick with the plus 4 for manganese and have 2 of the oxide ions to balance it. So the formula is MnO2. And finally for iron 2 nitride, iron 2 means Fe2 plus. Nitride is 3 minus, so we do the whole 3 and 2. Whenever you have 3 of one thing and 2 of another, multiply the 3 by 2 and the 2 by 3. That'll get you where you need to be every time. So Fe3N2. All right. Now we talked about writing the formulas for binary ionic compounds. Now let's talk about naming them. So when we're naming a compound, an ionic compound, all we do is write or say the metal name plus the beginning of the non-metal name with the suffix "ide." So again, 1, just name the cation. 2, name the anion, but take the end off from its name and replace it with "ide." So this compound here is sodium chloride. So the metal name sodium and the non-metal name with "ide" at the end. So sodium chloride. So go ahead and take a minute and see if you can name these compounds using that method. All right, so for number 1, it's calcium and oxygen, so calcium oxide. Number 2 is potassium and phosphorus, so potassium phosphide. Aluminum chloride, rubidium oxide, lithium oxide, and barium chloride. Very good, very good. All right, so when we're naming, sometimes we're going to have transition metals. Well, in order to write the name for a binary ionic compound containing a transition metal, we need to put a Roman numeral in the name to say what the charge is. So when we look at these compounds, we have to work backwards from the negative charge. So for the nonmetals, the negative charge will always, for the ions, will always be the same. But for the metal, certain metals, it can change. So we're going to use the charges we know to figure out the charges we don't. So we're going to work backwards from the charge of the anion. From it, figure out what the charge of the transition metal must be, and then write that charge in the name with the Roman numeral. So CrO, this is chromium and oxygen. Now, I know that chromium is a transition metal because it's in group 6. It's a transition metal. Oxygen, we know, has an ionic charge of 2 minus. Since there's only 1 chromium and 1 oxygen, that means that this compound the chromium must have a charge of +2, so this compound is chromium 2 oxide. Now for the Fe2O3, let me actually do this here on my paper. The oxygen always has a charge of -2. That means the total negative charge here, 3 times -2 will be -6. That means I have to have +6 to add to that to make it be neutral. So if I have 2 irons, each one would have to be +3 in order to make that be true. So this compound would be called iron 3 oxide. All right, so go ahead and practice. Go ahead and name these 4. All 4 of them have transition metals. All you have to do is, knowing the charge from the anion, work backwards to figure out what the charge on the cation must be. So pause the video and see if you can work that out. All right, so for the first one, FeCl3. I know chloride. It's a halogen, and all halogens have a charge of -1. Since there's 3 chlorines, the total charge must be -3. Since there's only 1 iron, that means that iron has to have a charge of +3 in order to make the compound neutral. So the formula is iron 3 chloride. For Cr2O3, I have 3 oxygen atoms here, and oxide ions always have a charge of -2. That means there's 6 units of negative charge So I have to have 6 units of positive charge. Since there's 2 chromiums, each one has to have a charge of +3. So the formula is, or the name, excuse me, is chromium 3 oxide. Moving right along, this compound is copper 1 chloride, because there's only one of each element, and chloride is always -1. That means copper here must be +1. And this compound down here is copper 2 chloride, again, because each chloride ion has a charge of -1, and there's 2 of them. In order to be neutral, copper has to have a charge of +2. All right, last thing we want to talk about is ternary ionic compounds. So you've seen me use that term binary. Binary ionic compounds only contain 2 elements, 2 types of elements. Ternary compounds contain 3 types of elements. So a polyatomic ion is an ion that consists of multiple atoms, polyatomic, covalently bonded together to create an ion that's made up of more than one atom. There are 6 polyatomic ions you have to know. You have to know their name and what their formula is. The first is called hydroxide, and it has the formula OH1-. The next is called nitrate, which is NO3 1-. Hang on one second. I'm recording a video. All right, coming back. All right, the next one is sulfate, SO4 2-, carbonate, CO3 2-, phosphate, PO4 3-, and ammonium, which is the only cation in this list, NH4 1+. Unfortunately, you have to just memorize these. The best way to do it is to write compounds that contain them, and I will give you plenty of that practice in class. All right, so let's go ahead and name these 2 and write formulas for these 2. All the same rules apply. So we have to check to make sure our metal is not a transition metal. If the metal is a transition metal, we have to work out what its charge would be. And for naming them, same thing. We have to figure out what the charge is and then how many of each ion we would need. So for this first one up here, sodium, it's sodium and carbonate. Sodium is not a transition metal, so we can just call it sodium carbonate. For this compound down here, this is iron and this is sulfate. Now, iron is indeed a transition metal, so we have to work backwards from the charge of sulfate to find out what the charge of iron is. So sulfate is -2, and there's 3 of them. That gives us a total negative charge of -6. That means there must be a charge of +3 on each iron. In class, I will give you a little shortcut for working this out. I just don't want to do it in the video because it's already getting kind of long. All right, so for barium nitrate, barium is +2. If you look at the previous slide, nitrate is -1, so I need 3 of them. Now, whenever we're writing a formula for an ionic compound that contains a polyatomic ion, if there are more than one polyatomic ion, then we put that ion formula in parentheses and indicate how many of them we have with a subscripted number outside the parentheses. So here we have 2 iron 3 ions and 3 sulfate ions. Here we have 1 barium ion and 2 nitrate ions. And finally, potassium hydroxide. Potassium is +1, hydroxide is -1, so the formula is KOH. All right, we're almost done here, we're almost done. All right, last thing we want to talk about is writing the formulas for molecular compounds, compounds that have covalent bonds. So this is completely separate from naming ionic compounds. To name compounds with covalent bonds, we use Greek prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. A lot of these you should know from your math classes. So if there's 1 of an element in a formula, we say mono. If there's 2 elements, we say di. If there's 3, we say tri, and so forth. All right, so let's go ahead and practice with these. Dinitrogen trioxide. Dinitrogen means 2 nitrogen. Trioxide means 3 oxygen, so it's N2O3. Now, if we look here at number 14, phosphorus pentafluoride, if there's ever 1 of the first element, we don't use a prefix. It's not monophosphorus pentafluoride, it's just phosphorus pentafluoride. But if there's a lack of prefix on the first element, it just means there's one. So phosphorus pentafluoride is PF5. Tetrasulfur means 4 sulfur. Diiodide means 2 iodines, so S4I2. Now, we got to know those prefixes when we're naming them. 2 silicon, 6 chlorines is disilicon. Hexachloride. NO2 is nitrogen dioxide. Again, 1 nitrogen. We don't write mononitrogen, we just write nitrogen. And down here, P2O10 would be diphosphorus decoxide. So summing up, steps to naming the compounds. There are different rules for ionic and covalent. Ionic, we just say the names of the ions. Covalent, we use the prefixes. So the first question you need to ask yourself is the compound ionic or covalent? If it's covalent, you just go ahead and name it using your prefixes. Mono, di, tri, tetra, etc. How do you know if it's ionic or covalent? If there's a metal in the formula, it's ionic. If it's all nonmetals, it's covalent. If it's ionic, we need to ask a few other questions. One, is the metal a transition metal? If it is, you have to figure out what the charge is for when you're writing the Roman numeral. If it's not a transition metal, then you just name it by saying the metal name, the non-metal name with "ide." Last thing you got to ask yourself, is there a polyatomic ion? If there is, you got to make sure you use the suffix "ate." If you're creating the formula from a name, you'll know there's a polyatomic ion because it ends in "ate." So if we look back at our list of polyatomic ions here, hydroxide ends in "ide," but 8, 8, 8, 8. If you see 8, it's going to be one of those 4. And that is it for this discussion, kiddos. There is a final slide here, the naming challenge. So wherever you see a formula, go ahead and name it. Wherever you see a name, go ahead and write the formula. We are going to do this as a warm-up in class, so you don't have to do it now, but it might be worth filling it in just in case. All right, kiddos, you have a great one. Thanks for watching, and I'll see you in class.